This is 9. That's way too big of a marker. There we go. This B is 9 and A is -3. So we'll have -3s there throughout, and the B again is 9. This would be a -3. Plus a -3 is -6. Square that to come up with a 36. This is going to be 6. Times a -3 is -18. So 36 plus a -18 should be 18. Alright, so we're going to have an x of 2, and then a y of 3, and a z of -1. So on the front part, 2 squared is 4, times 3 is 12. And then inside here we have a 1, squared is 1, times 3 is 3. And then take away 2. So that's 15 minus 2, which should be 13. So R is 4, and S is -2. T equals R, and R is 4. So out front you start with a 4 plus. This is 0, squared is 0, times -2 is 0. And then 4 squared is 16, times a -2 is a -28. So you end up with 4 plus a -28. Not 4 plus a -28. It should be, yeah, it's a -32. Did I say -32? I skipped straight to the answer though. So it's plus a -32. So 4 plus a -32 is going to be a -28. The winning number is 5. We have 13 out of 21, which is what percent? 61%. Here are the answers. We'll go through any questions you have after we get through these. On the first one, it should be 4i square root of 5, plus or minus 4i square root of 5. 2 is plus or minus 5i square root of 7. 3 is plus or minus 7i square root of 3. 4 is plus or minus 12i square root of 2. And 5 is plus or minus 3i square root of 11. On the practice problem, let's start with x minus 5 and x plus 6. And multiply to get x squared plus 6x minus 5x minus 30 equals 0, and simplify the middle to get x squared plus x minus 30 equals 0. Let's say we have roots of 0, -2, and 6, and it's going to be a third degree. Here's how you would set it up. For the root of 0, you would put x plus or minus 0, whichever. It's not going to change anything. And then x plus 2 and x minus 6. So this is the part that is different. You can just make that x because the 0 makes no difference, and then multiply out the other 2 to come up with x squared minus 6x plus 2x minus 12, and simplify it to get x squared minus 4x minus 12. And the last thing to do is multiply everything by x. So you get x to the third minus 4x squared minus 12x equals 0. (36) divided by negative 6 is negative 6. If I do the opposite from this and add 2, I come up with a negative 4. A complex number system. Know the fundamental theorem of algebra. Show that it is true for quadratic polynomials. So the fundamental theorem of algebra, at least this part, is every non-zero, single variable, degree n polynomial with complex coefficients has, counted with multiplicity, exactly n roots. And that's a lot easier to understand than what it sounds like. And you'll see what I mean when we go to an example. But before we do that, you have to understand when I say roots, you're talking about negative 3 and negative 2 from something like that. So in other words, the solution. And what this translates to on a graph is that negative 3 and 2 are where the graph is going to cross the x-axis. That's what those mean, and we'll look at graphs later on after we get familiar with this. So here's example 3. Create a polynomial of the third degree that has roots of 4, negative 3, and 2. So now we're going in reverse. Before, you were given a polynomial and you had to solve for the answers. Now, you get the answers, you have to create the polynomial. Here's how you do this. Remember that 4, negative 3, and 2, if they are solutions of the polynomial set equal to 0, then what did we have to do to these numbers before we actually arrived at this point? There's one little operation you have to do. Once you have them factored out, what do you do to get to 4, negative 3, and 2? You change the sign. So in other words, it had to look something like this. So instead of x plus 4, it's x minus 4. And then it's going to be x plus 3 and x minus 2. So you put them back into your factored set of parentheses in reverse form. Minus 4 plus 3 minus 2. And then you have to go through and multiply these out to come up with the polynomial. Just do this part first, here, and use the first outside, inside, last method, and do x times x is x squared, x times 3 is 3x, negative 4 times x, and negative 4 times 3. But remember, that's all in a set of parentheses. Simplify that before you go through and multiply by x minus 2. So that would be x squared minus x minus 12. 3x minus 4x is minus x. Now multiply by x minus 2. So x times x squared is x to the third. X times a negative x is negative x squared. And x times a negative 12 is negative 12x. Go to the minus 2 now. Minus 2 times x squared is minus 2x squared. Minus 2 times minus x is plus 2x. And minus 2 times minus 12 is plus 24. So clearly you're going to have to simplify. How many x to the thirds do I have? You have 1, so it's x to the third. How many different x squared terms do I have?
2.
So I have negative x squared minus 2x squared to get what? Negative 3x squared, and I have 1 and 2 x terms. Negative 12 plus 2 is what? So it's negative 10x, and then the 24 is just by itself. So this here at the bottom, x to the third minus 3x squared minus 10x plus 24 equals 0, is your answer. That's the polynomial that's going to give you the answers of 4, negative 3, and 2. Alright, create a polynomial of the second degree that has roots of negative 3 and 7. So if I go through and do this, x and x, what am I putting in the parentheses? Plus 3 and minus 7, the opposite of what's up there. So now if you multiply this out, x times x is x squared, x times negative 7, and then 3 times x, and 3 times negative 7. You'll have to simplify the middle terms and come up with what from negative 7x plus 3x? Negative 4x. So now if you went backwards and you had to come up with two numbers that multiply to get negative 21 and add to get negative 4, you would have a positive 3 and a negative 7. So we just go backwards. And this is, you don't have to do anything beyond this point here. This is the answer. I'm just showing that when you factor it out and go backwards and then solve it, you end up with these two numbers that were given to you in the problem. Try this one and bring it up here. I just need the equation, and it has to be simplified and set equal to 0. Create a third degree polynomial with roots of negative 1, 2, and 5. Let's lower this down so I have some room to work. Well, there goes my screen. That's strange. I need to start making these a little larger. We'll just have to work with it. Alright, so you're going to have x plus 1, x minus 2, and x minus 5. All of that set equal to 0. Remember, we put in the opposite of these. Let's multiply these two to get x squared minus 2x plus x minus 2. And then we'll have to go back and simplify that before we multiply. You don't have to, but it makes it a lot easier. That would be x squared minus x minus 2. And let's multiply that by x minus 5. To get x to the third minus x squared minus 2x minus 5x squared plus 5x plus 10. And simplify to get x to the third minus 6x squared. And when we go to this, it'll be negative 2x plus 5x is 3x. And then you're just going to have a plus 10 left over. So if you have what's at the bottom, you can come on up and claim it. For the bonus, it is negative 3x plus 2x equals 11 plus 9. That's a negative x equals 20, but you have to divide both sides by a negative 1. $12x minus 8x equals 32 minus 16. That's 4x equals 16. Only divide by a negative number when you have a negative number there. So 16 over 4 is going to give us an answer of 4. Oh my gosh. Alright, you're going to have x plus 7 and then x minus 8 equals 0. When you multiply, it's x squared minus 8x plus 7x minus 56 equals 0. And simplify the middle. X squared minus x minus 56 equals 0 is your answer. You need a number to multiply by 4 to get 24. What number is that? It's 6. Whatever this is, do the opposite. Answer is 8.